Today, let's complete the square. But first, let's talk about what a perfect square trinomial looks like. On the first problem, both the first term and last term are squares. What are they the squares of? Well, x squared comes from x, and 16 comes from 4. Secondly, the last term must be positive, and it is. The last rule, number 3, is about the middle term. The middle term is twice the product of the roots from the first and last. So you take x and 4 and multiply them, that's 4x, and double it to get 8x. Now when we factor, we use the roots of the first and last, and now the sign that's in the middle. So you get x plus 4 squared. Done. Same thing on this second problem. On the second problem, 4x squared comes from 2x and 9 from 3. 2x times 3 is 6x, which doubles and makes 12x. It factors as 2x minus 3 squared. Excuse my stylus writing. On the third problem, what makes that a perfect square trinomial? Well, let's work backwards. 6x is from doubling 3x. 3x is the product of the roots from the first, which is x, and the last, which must have been 3. 3 was the square root of the last term, which makes it 9. So x squared minus 6x plus 9 is a perfect square trinomial, which factors now as x minus 3 squared. So x minus 3 squared. Done. This last problem is a little trickier. On the last one, we need to factor this negative 3 out front. This is a technique that you're going to see a lot more of with conic sections. We have to factor it from both of these terms shown. So we take a negative 3 from both of them, giving us x squared plus 2x, and still plus a blank. Well, as in above, 1 makes a perfect square trinomial, and it's negative 3 times that 1 that has to go up top here, and it's the negative 3 that we factored out that goes in front with the factoring. Also, x squared plus 2x plus 1 factors as x plus 1, quantity squared. So negative 3 completes the square, and this factors as negative 3 times x plus 1 squared. Done.